What is up, Algebra 2? This is Lesson 81. Our objective is, how do you work with complex numbers? Well, first of all, what is a complex number? And I think we've talked about this before, but just in case you don't remember, it is a plus bi. It's a number that can be written in this form, a plus bi. Remember, I is that Euler's form for the imaginary number, the square root of -1. So 2 plus 3i, that's a complex number. 4i is a complex number as well because it can be written as 0 plus 4i. -3 plus 2i, that's in that form as well, or just 7, right? Because that would be 7 plus 0i. Well, 7 looks pretty familiar. That's a number we're used to working with, and that's a normal real number. And really, any real number, like the square root of 2, pi, the square root of 7, all real numbers can be written as complex numbers using kind of this idea right here. So the real numbers, the ones we have been working with, is what we call a subset of the complex numbers. So every real number is also a complex number. So let's work with adding and subtracting complex numbers. Really, to add or subtract, maybe I should make a quick note of this. A plus bi. The blue part, the A, is what we call the real part, and B is what we call the imaginary part. So to add or subtract, you simply just add the real parts and you add the imaginary parts. So let's go with these. I'm going to say -3 plus 5. So it's going to come out with 2. And then it's going to be plus 4 plus 6, which comes out to be 10i. So if you want it in one color, 2 plus 10i. This next one's subtracting. And kind of just think of it like this. This would be 6 minus 2i minus 7 plus 8i. Because this is minus that and that. And minus makes it a plus. So you can also think of it just combining like terms. Here's 6 minus 7, so that gives me -1. -2i plus 8i gives me plus 6i. And kind of same idea here. If you want to, just kind of drop those parentheses because they're not actually doing anything. Minus I minus 8. Well, that I minus I comes out to be 0. So -5 minus 8. Same sign, so you add them. It comes to be -13. Alright, multiplying. To multiply them, we're going to FOIL, which remember stands for first, outer, inner, last. So the first is 3 times -3, which comes to be -9. Outer, 3 times -i gives me -3i. Inner, -7i times -3 gives me +21i. And last, -7i times a -i is going to give me plus 7i squared. Remember, I squared is equal to -1 because I is equal to the square root of -1. So this part right here is equal to -1. So I'm going to have -9 minus 3i plus 21i minus 7. Combining like terms, these two give me -16. These ones give me, what is that, 20 plus 18. I don't know why I switched colors on you there. Sorry about that. Alright, now 11 is really the same idea as number 7, except they wrote it a little bit different way, because remember, x squared really just means x times x. So this is going to be -6 plus 5i times -6 plus 5i. So again, we're going to FOIL. So first, 6 times 6 is 36. Since they're both negative, it becomes positive. Outer, that comes out to be -30i minus 30 more I, and last is going to be plus 25i squared. Remember, that's equal to -1. So 36 minus, I'm going to go and combine those two, 60i minus 25, so it's going to be 11 minus 60i. It's also worth noting that I'm writing all my answers in that a plus bi form. You wouldn't really, so like this one I wouldn't want to write minus 60i plus 11 because that's not in that proper form. Alright, and then dividing. And really when it says dividing, we're just trying to rationalize. And rationalize, maybe an easy way to remember that is to remember that we're not supposed to have any radical parties in the basement. Well, radical parties, we're used to seeing stuff like that. We're not supposed to have those in the basement. But remember, I is equal to a radical. So we would like to try to also get i's out of those denominators. So if you remember our trick to get rid of those is to multiply by the conjugate of the denominator. So 3 minus 10i. And 3 minus 10i. Remember, this is really just a big 1, right? So I'm not changing the value of it. So let's multiply the top. This is going to be 5. Don't want a highlighter. 5 times 3. So 5i times 3 is going to give me 15i. 5i times negative 10i is going to give me negative 50i squared, which you can remember that's equal to negative 1. My denominator is what we're trying to take care of here. We're talking about foiling these, so first outer, inner, last. Since those are conjugates of the other, the middle term is going to cancel out. It's going to be 9. And then this times this is going to be negative 30i plus 30i, so those go to 0. And this times this is going to give me minus 100i squared. Remember, I squared is equal to negative 1. So this is going to equal to positive 50. That's what this part right here turned into, because it was a negative 50 times negative 1, changing that positive 50, plus 15i over this part right here turns into a positive 100 plus 9. So this is going to be 109. And we're tempted to leave it that way, but remember when we're writing that a plus bi form, this is going to be 50 over 109 plus 15 over 109i. One more, just where we have to FOIL the top and the bottom. I'm going to multiply this by the conjugate of the denominator, so it's going to be negative 9 plus I. So FOIL the top, FOIL the bottom. The top you get 81 minus 9i minus 36i plus 4i squared. Denominator is going to come out to be 81 minus an I squared. So the denominator is going to be 81 plus 1, it's going to be 82. Remember, this is equal to negative 1, same with that, that's how I got that. So it's going to be minus 4. So 81 minus 4 is 80 minus 3, so 77. Combining these two together, you get minus 55i. Then we just want to write it in that a plus bi form, so I'm going to say 77 over 82 minus 55 over 82i. Alright, your homework is a worksheet, so make sure you've grabbed that. And again, all these on here were from your worksheet, so make sure you copy those down and get those right. Good luck, guys.